All right, let's go into it. Hello, everyone. Today we will see how LLMs can change the way that we build a API specification. So we have Anna today with us, but also it's a joint project with Hongliu and Minji from Amadeus. So let's go into it. First of all, a bit of presentation today. Well, this is me and my cat Nota. I guess you will know who is who. We are tired a bit, but I think it's clear. I'm a data scientist. I've been working in Amadeus for 7 years already in the Amadeus research team in Madrid. So pretty hot these days. And we have Anna as well today. So Anna, hello.
Thank you, Jorge, and hi, everyone. I'm Anna, and in this photo, I'm with my dog, Oscar. He has been my best friend for over 11 years. I could spend the rest 20 minutes talking about him, but no, I will focus on our topic. So I'm a developer advocate at Amadeus, and my main role is to improve developer experience, also engage with our users, and gather feedback as well for them in order to be able to improve our solutions and products that we offer to them. To give you a bit of background how this collaboration started between our teams, a few months ago in my team, we wanted to build a chatbot using GenAI in order to help API designers and developers update their API specifications. And back then, to be completely honest with you, I didn't know much about GenAI. I was just a regular ChatGPT user asking for advice. But thanks to all the internal resources and external as well that I was able to find, plus some knowledge from people in Amadeus, my colleagues and I were able to build a first version of the chatbot pretty easily and quickly. So this first version was working well. However, we realized that there were some cases that the chatbot was not handling well at all. We tried different methodologies trying to fix the chat, to overcome the challenge, but we were blocked. And one day, I met Jorge at the office that back then we were not working closely together. I explained him the situation and what we're going through. And that discussion that I had with Jorge made me realize how much the knowledge of a data scientist can bring into a project like this. So what we're going to see in this session today, we're going to talk about the GenAI chatbot, and also we're going to have a live demo in case there are no demo effects. And then we're going to talk about the main challenge that we faced and how we were able to handle large API specification files. So to give you a bit of context and how this idea came with a chatbot, in Amadeus, we built a platform which is called Creation Platform, which is a set of shared technical and business capabilities built on top of cloud technologies. The reason why in Amadeus we decided to build this platform is because we wanted to allow developers build new solutions and improve as well existing ones by increasing the value while being able to reducing the cost. And the main objective is to empower Amadeus employees, our customers and partners. And one of the main capabilities of this platform is called API extension. So what we want to do exactly with API extension is we want to allow users update an API and add some new features to it. For example, imagine you have one API that returns hotel, but it doesn't return images of the hotels. So in this case, maybe there is someone who wants to update the existing API and add a new field which returns these hotel images. So there are two steps that need to be done for an API extension. The first is to update the API specification, and the second one is to implement the new feature of the API. And where we really wanted to help was with API specification modification. And we wanted to build a chatbot that we're going to show you today in order to allow users give us input, the initial API specification, and get us output the updated one with the chatbot. So what we really expect from the chatbot is As the example here, we have an initial API specification. In this case, there is one API which returns popular travel destinations. And the output of the chatbot will contain the new fields. In this case, we wanted to add some fields for ratings. So this is automatically generated by the chatbot. So now that we saw a bit of the context, let's get into more details of the chatbot. And first, you might wonder why we wanted in first place to build a chatbot using AI to help developers and designers, API designers, update API specifications. The first reason is based on our own experience, we saw that not everyone is an expert and not everyone knows the best practices or is super familiar with API design. So we thought it could be useful for the people that lack this knowledge. And at the same time, it can minimize the manual effort. And finally, we thought that by having a chatbot and basically using AI, we can enforce some standards and company guidelines that can be embedded there. So when we get the output, the new API specification to be based on these guidelines. Now, let's have a look at the solution that we built. So we're going to see the workflow and the technologies as well we use step by step. So we have a user who wants to update an existing API. And the user is asking, extend this API that I uploaded. We are going to upload later, you will see in the demo the API specification. So extend this API and add ratings per destination, let's say, as an example. The user is on the chatbot, which is built with Streamlit, and Streamlit is a popular framework to build UI interfaces in a quick and easy manner. So with this framework that we build the chatbot, we get the query from the user as well as the API specification, and we pass it to OpenAI. So we make an API call to OpenAI, and what we get back is the extended API specification, which is being sent to the user through the chatbot. So this is the main solution and workflow of the solution that we built. And now I'm going to show you in action how this works. I will start now the server and I will share my browser. Just give me one moment. Okay. I will share again my screen. Okay. Here we have the chatbot, the user interface. And we're going to upload an API specification. In this case, we uploaded the airport routes API, and now I'm going to ask to do an update. So I will say extend the API, add ratings per destination in the response, as an example. While this is running behind the scenes, I'm going to show you the API, how the initial API specification works, and we will compare it with the result that we're going to get. So here I am in the Amadeus for Developers portal, where we can find some APIs that I'm using for this chatbot. So we're going to get the airport routes API, which is basically allowing users get direct destinations that then can go from a given airport. And if we go to the API reference, we're going to see that the current version of the API that we uploaded is the version 1.1.0, and the example response, so you can later be able to compare easily, what returns is a list of destinations, and for each destination we get the name, the address, time zone, and some metrics such as relevance. So now we'll go back to the chatbot, and as you can see, we get the response, in this case the changes that happened, and then the API specification. So I'm going to copy the specification and paste it in the Swagger editor because it will be easier to see how it looks like. Okay, so I have copied it here and I'm pasting it. So the first thing that we notice here is that the version has been updated. Before it was the version 1.1.0, now it's the version 1.2.0. And if we are going to see the example, you will see that in the metrics, there is one field which has been added, which is called rating. And if we go to the schema, you will see that there is the field rating with a description as well as its type. So this was one example that in this case, we uploaded a file, we asked it to be extended, and we got the full new Swagger file. Now, I would like to show you a second example that I started before the talk, which looks a bit different. Now I uploaded a different API, the flight offer search. This API returns flight offers. And here the response looks a bit different. So we see how we can update it step by step. So we see step 1, step 2, step 3, what needs to be changed, and then we're getting a subset of the Swagger. So you can see that, for example, the parameters is not full. Same for the definition details, the other data, the example data, etc. So now I'm going to leave the floor to Jorge to explain us why this response looks a bit different from the one that we got before.
Thank you, Anna. Yes, I will continue with the presentation. So indeed, what is happening? Why the two examples are different? Well, it's basically a context length problem, right? So I can tell you that the second Swagger that Anna tried to extend, it was way larger than the first one, right? And we know that when we are dealing with large language models, the context it's important, right? So at that time we were using GPT-4, and it has a maximum output token length of 4,000 tokens. Okay, so it means that if we want to extend an API specification larger than 4,000 tokens, we will have a problem, right? And indeed, we were, I mean, the Amadeus for Developers portal, we have swaggers that are larger than 100,000 tokens or something like this, right? So there is a problem here that we need to solve, and this is what I will explain you in these last minutes. I feel like it's interesting to show you not what it worked at the end, but all the things that we try in the meantime, because we always focus on the success. Oh, this technology works the best, but how you reach this, how you reach the solution, right? I think it's interesting to explain what I tried before, what we tried, and at the end it didn't work. So one thing you may be wondering is, okay, you can do random split, right? So you have this big Swagger file, the API specification. You try to break it randomly, let's say, and then you ask the model for every chunk, like, do I need to do the modification or not? And if I need to do it, just do it for me, right? At the end, we want the model to do our job. Well, I can tell you this thing didn't work. Second thing that, well, it has been totally mentioned before during this conference is about RAG. And again, it didn't work. So, as a data scientist, sometimes we try to solve the things quite fast, but it's good to sit down and analyze what you have in your hands. I have no idea of API specifications, no idea about swaggers. So the first thing, it was like, okay, let's see what we have. So they are JSON files, good. They are hierarchical, right? So we have key values, and it can be highly nested, right? So it can have like a really depth level, right? Deeper levels. Intercorrelation, this is something we discover. So there are internal references, right? So there are jumps between parts of the file. So if you need to modify one chunk, maybe there is an internal reference to another chunk of the file, right? So then how are you going to modify this chunk if it is pointing to some content that the model doesn't know? We need to deal with this. Third point, we have code rather than text, right? So when we are dealing for RAG, for example, everything works on semantic similarity, right? So it's more appropriate for text with books, documentation, things when you clearly put words that mean something. Here is more about specification, response models, things that maybe are more close to code rather than text. And then the last point, which was it was really like a headache, is that the extension is not always done on the same fields. So we were dealing with different API specifications, and in some of them, I had to touch this kind of fields, and for other specifications, I had to touch different fields, right? So it was a bit hard to generalize. So this is the thing. We first try to understand the problem, and then we try to modify it and to tackle the issue, okay? Well, first thing we did is, okay, let's exploit the hierarchical structure, right? So we have JSON. So then we can build a tree relatively easy, right? So a tree is composed of three nodes and leaves, and this match perfectly well with the file. And this is relatively easy to do in any library. So good, we build a tree out of the JSON. And then the second thing that we accomplished is to group the tree nodes, okay? How we group them? Well, we fix a number, n in this case, that is basically the number of tokens that we can put into these groups. So if we have a small tree nodes, it means that we can add more tree nodes into the group. Good. If they are heavier tree nodes, like with more tokens, maybe I can fit only one of them. Or if it's even larger than this number, it means I need to go one step down into the structure and go to the inner subtree and so on, okay? So we group this, and then we did a chain summarization. So I will tell you what it is, but it's basically for each of the groups that we previously defined, we're just gonna do a summarization, right? And then the output, I mean, this kind of partial summary plus the next group of nodes, I can do a summarization again, right? So I'm just chaining all this summarization until we reach the end, and the end will be the summary of the full Swagger, okay? Why are we doing this? Well, this is a way for us to, for example, resolve all the internal references, right? In the summarization step, we ask the model, in case there's an internal reference, just resolve it, right? We want to get rid of this. And another thing is that we need to run this process only once per API specification. So in case we want to do multiple extensions over the same file, we're just gonna reuse the summary. And I will tell you how it looks like. So it's basically plain text file that is kind of easy to understand for us, and it contains the minimum and relevant information for the model to perform an extension. So then the next step will be adding what the user wants to do. So as Anna mentioned before, in this case, you want to add the probability for each flight. And then the model will return the step-by-step instructions as Anna mentioned in the demo. So it doesn't return the full Swagger, it will return what you need to do if you want to modify it. And then there is a question. Okay, everything is so good, but at the end, you are not doing, I mean, you are doing the job. It's me who has to modify it, right? So why are we generating instructions? Well, a few points. Of course, point number one, we are overcoming the issue with the maximum output token number that I explained you before, right? Definitely instructions have less token than the full Swagger, so good. And of course, because it has less tokens, it means that it's cheaper, right? We pay per token typically, and it's faster, right? There is less token to generate, so you build the response way faster. Third point that I think is always important to mention, everyone is talking about GenAI, how GenAI is so cool, and I partially believe it, but you need to test it, right? You need to prove that what you're doing is a valid solution, right? GenAI is very good to look like that the solution is good, but maybe it's not good. So if we have a list of instructions, we can easily, humans, test that what the model is suggesting is good or bad. And if it's bad, we can try to fix it, right? If we look at the full Swagger, it will be hard for us to know if it's good or bad. Of course, there are tools like what Anna showed that it will tell us if there is a syntactical error, okay? But there can be other errors that are harder to spot. So if you have a list of things to check, it's easier. And then the last point is about robustness, and this is linked with the model determinism. Um, sometimes you want to control temperature or the parameters, and then same runs can give you different outputs. And then we prove that if you want to generate Swagger, like a full Swagger, a slightly variation, it can make everything to not working really, full of errors. And a small variation in a list of steps is more robust, right? So it's a more resilient way to proceed when we generate steps than the full Swagger. And I will leave the floor to Anna for the final takeaways. Floor is yours.
Thank you, Jorge. So, as key takeaways, there are a few things that we would like to conclude. The first one is that it's pretty easy to start and build your first GenAI applications or prototypes because there are so many tools, documentation, and resources that can be used. So there is a lot of knowledge out there. However, for some specific cases and challenging cases as well, you definitely need the expertise of a data scientist. At least this was our own experience because I was not familiar with all the terminologies, all the models, and all the technical details that maybe a data scientist knows. So we truly believe that their expertise can be very useful. And finally, you need to be open-minded and flexible to keep up with the changes. So there are new models that they have a larger input and token limitation, for example, that maybe could cover, if you face the same challenge as us, for example, it could maybe help you solve the challenges faster. And maybe you have spent a lot of time, a lot of months working on your own solution, your own workaround, and maybe there is a moment that there is something better out in the market. So things change all the time. So it's good to be open-minded and flexible to keep updating and improving your solutions. Thank you so much.